NEC Section 300.22 current states that Schedule 40 PVC conduit can be used for concealing electrical conductors in building walls. A 4-inch conduit is acceptable for running voice and data cables. Therefore, you are allowed to use 4-inch PVC conduit within the outside walls of the building. Using drain pipe is not recommended as it may not meet the strength and fire resistance requirements of electrical conduit. NEC Section 300.22c5 dictates that openings in fire-rated walls and partitions must be fire-stopped with approved materials. If the drywall on the outside walls is fire-rated, it is important to maintain its fire resistance. To access the conduits for cabling, you can cut out sections of the drywall, but you must fire-stop around the conduits using an approved method. This could include using fire-rated sealant or installing fire-rated collars or wraps around the conduit penetrations. The recommended procedure involves several steps. Firstly, cut a 2x section of drywall where you need to access the conduit. Secondly, use the conduit hole saw to drill a hole for the conduit to pass through. Thirdly, fire-stop around the conduit using an approved method. Fourthly, run the cables through the conduit and into the desired location. Fifthly, seal the drywall opening around the conduit with fire-rated sealant. By following these steps, you can maintain the fire resistance of the drywall while providing access to the conduits for future cabling needs. Fire stopping is a crucial aspect of maintaining the integrity of fire-rated walls when penetrations are made for conduits or other services. The purpose of fire stopping is to prevent the spread of fire and smoke through these openings, thereby compartmentalizing the building and providing occupants with more time to evacuate safely in the event of a fire. Fire-rated walls are designed to withstand fire for a specific period, typically measured in hours such as 1 hour, 2 hours, or more. This fire resistance rating is achieved through the use of specific materials and construction techniques that slow down the spread of fire. When a hole is created in a fire-rated wall for a conduit, it compromises the wall's ability to resist fire. The open space around the conduit can allow flames and smoke to pass through, undermining the fire protection provided by the wall. Fire-stopping materials are specially designed to fill these gaps and restore the fire resistance rating of the wall. These materials can include fire-rated sealants, putters, collars, wraps, and mineral wool insulation. Each type of material has its own specific application and installation requirements. Fire-rated sealants are typically used to fill small gaps and cracks around penetrations. They expand when exposed to heat, creating a tight seal that prevents the passage of fire and smoke. Fire-rated putters are similar to sealants but are often used for larger openings or for sealing around irregularly shaped penetrations. Fire-rated collars and wraps are designed to be installed around pipes or conduits that penetrate fire-rated walls. They contain intumescent materials that expand when exposed to heat, crushing the pipe or conduit and sealing the opening. Mineral wool insulation is often used to fill larger voids in fire-rated walls. It is a non-combustible material that provides excellent thermal and acoustic insulation. When selecting fire-stopping materials, it is important to choose products that are specifically tested and approved for use in fire-rated walls. These products should be listed by a recognized testing laboratory, such as Underwriters Laboratories or FM approvals. The listing will specify the types of penetrations the material is approved for, the size of the opening it can fill, and the fire resistance rating it can maintain. Proper installation of fire-stopping materials is essential to ensure their effectiveness. The installation should be performed by qualified personnel who are familiar with the specific requirements of the product and the applicable building codes. The installation should be inspected to verify that the materials are properly installed and that all gaps and openings are completely sealed. In addition to fire stopping around conduits, it is also important to consider fire stopping around other types of penetrations such as pipes, cables, and ducts. Each type of penetration will require a different type of fire-stopping material and installation method. Regular inspections of fire-stopping systems are recommended to ensure that they are in good condition and that they have not been damaged or compromised. Any damaged or missing fire-stopping material should be replaced promptly. By properly fire-stopping penetrations and fire-rated walls, you can help to protect occupants from the hazards of fire and smoke and ensure the safety of the building. When working with electrical systems and fire-rated walls, it is crucial to adhere to the National Electrical Code (NEC) and local building codes. These codes provide detailed requirements for the installation of electrical equipment and the protection of fire-rated construction. The NEC addresses the use of conduits in various environments and provides guidelines for maintaining the fire resistance of walls and ceilings. Article 300 of the NEC covers general wiring methods and materials, including the use of conduits. Section 300.21, Spread of fire or products of combustion, specifically addresses the need to maintain the fire resistance rating of walls, floors, and ceilings that are penetrated by electrical raceways, cables, or equipment. This section requires that the fire-stopping methods used must be approved for the specific type of penetration and the fire resistance rating of the assembly. The NEC also addresses the use of specific types of conduits, such as PVC conduit, in different environments. Section 352.12, Uses not permitted, outlines the situations where PVC conduit is not allowed, such as in ducts or plenums used for environmental air, unless specifically approved for such use. However, as stated in the earlier response, Schedule 40 PVC conduit is generally permitted for concealing electrical conductors and building walls, as long as it meets the applicable requirements. When cutting into fire-rated drywall to access conduits, it is essential to follow the recommended procedure and use approved fire-stopping methods. The size of the opening should be kept to a minimum, and the fire-stopping material should be installed in accordance with the manufacturer's instructions. It is also important to ensure that the fire-stopping materials are compatible with the conduit material on the surrounding drywall. In addition to the NEC, local building codes may have additional requirements for fire stopping and the installation of electrical systems and fire-rated construction. It is important to consult with the local building department to ensure that all applicable codes are followed. Failure to comply with these codes can result in fines, delays in construction, and, most importantly, a compromised level of fire safety. When selecting and installing conduits and fire-stopping materials, it is important to consider the long-term maintenance and accessibility of the electrical system. Conduit should be installed in a way that allows for future access for cabling and maintenance. Fire-stopping materials should be selected that are durable and resistant to damage from moisture, chemicals, and other environmental factors. Regular inspections of the electrical system and fire-stopping systems are recommended to identify any potential problems and ensure that the system is functioning properly. Any damaged or missing component should be repaired or replaced promptly. By following these guidelines, you can ensure that the electrical system is installed safely and in compliance with all applicable codes, and that the fire resistance rating of the building is maintained. Remember that working with electrical systems can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical shock and other hazards. Always disconnect power to the circuit before working on any electrical equipment, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work. They will have the knowledge, skills, and experience to ensure that the job is done safely and correctly. The use of appropriate tools is essential for the safe and effective installation of conduits and fire-stopping materials. A conduit bender is used to bend conduit to the desired angle, allowing it to be routed around obstacles and through walls and ceilings. A conduit cutter is used to cut conduit to the desired length. A conduit reamer is used to remove burrs and sharp edges from the cut end of the conduit, preventing damage to cables. A hole saw is used to drill holes in drywall and other materials for conduit penetrations. A caulking gun is used to apply fire-rated sealant to gaps and cracks around penetrations. A putty knife is used to apply fire-rated putty to larger openings. A tape measurer is used to measure distances and ensure that conduit is installed properly. A level is used to ensure that conduit is installed level and plumb. A wire puller is used to pull cables through conduit. A cable stripper is used to remove the outer jacket from cables. A crimping tool is used to crimp connectors onto cables. A multimeter is used to test the continuity of circuits and ensure that they are properly grounded. In addition to these tools, it is also important to have a variety of hand tools such as screwdrivers, pliers, and wrenches. These tools will be needed for various tasks such as tightening screws and bolts and making adjustments to equipment. When using tools, it is important to follow the manufacturer's instructions and to wear appropriate personal protective equipment, such as gloves and safety glasses. This will help to prevent injuries and ensure that the job is done safely and effectively. The selection of appropriate conduit fittings is crucial for ensuring a secure and reliable electrical system. Conduit fittings are used to connect sections of conduit together to connect conduit to electrical boxes and equipment, and to provide access to the inside of the conduit for wiring and maintenance. There are many different types of conduit fittings available, each designed for a specific purpose. Some common types of conduit fittings include couplings, connectors, elbows, tees, and bushings. Couplings are used to connect two sections of conduit together in a straight line. Connectors are used to connect conduit to electrical boxes and equipment. Elbows are used to change the direction of conduit runs. Tees are used to create branch circuits from a main conduit run. Bushings are used to protect cables from abrasion as they enter or exit conduit. When selecting conduit fittings, it is important to choose fittings that are compatible with the type of conduit being used. For example, PVC fittings should be used with PVC conduit, and metallic fittings should be used with metallic conduit. It is also important to choose fittings that are rated for the environment in which they will be used. For example, fittings used in wet locations should be rated for wet locations. The installation of conduit fittings should be done in accordance with the manufacturer's instructions and the applicable electrical codes. Fittings should be securely tightened to prevent them from coming loose over time. When connecting conduit to electrical boxes and equipment, it is important to ensure that the connection is properly grounded. This will help to prevent electrical shock and ensure the safety of the electrical system. Regular inspections of conduit fittings are recommended to ensure that they are in good condition and that they have not been damaged or corroded. Any damaged or corroded fittings should be replaced promptly. By selecting and installing appropriate conduit fittings, you can help to ensure a secure and reliable electrical system. Grounding is a critical aspect of electrical safety. It provides a path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. This helps to prevent electrical shock and fire hazards. The National Electrical Code (NEC) provides detailed requirements for grounding electrical systems. Article 250 of the NEC covers grounding and bonding. Section 250.4 states that grounding shall be installed in a manner that creates a low-impedance ground fault current path and facilitates the operation of the overcurrent protective devices in the circuit. This means that the grounding system must be designed to provide a clear and reliable path for fault current to flow back to the source. There are several different types of grounding systems, including equipment grounding, system grounding, and bonding. Equipment grounding is the connection of non-current carrying metal parts of electrical equipment to ground. This includes the metal enclosures of electrical boxes, conduit, and equipment. System grounding is the connection of the neutral conductor of an electrical system to ground. This is typically done at the service entrance. Bonding is the connection of metal parts of a building or structure to ground. This includes metal piping, metal siding, and metal roofing. The purpose of bonding is to create a common ground potential throughout the building, preventing voltage differences that could cause electrical shock. When installing a grounding system, it is important to follow the requirements of the NEC and local building codes. The grounding system should be inspected to verify that it is properly installed and that it provides a low-impedance ground fault current path. Regular inspections of the grounding system are recommended to ensure that it is in good condition and that it has not been damaged or corroded. Any damaged or corroded components should be replaced promptly. By properly grounding electrical systems, you can help to prevent electrical shock and fire hazards. Overcurrent protection is another critical aspect of electrical safety. It is designed to protect electrical circuits and equipment from damage caused by excessive current flow. Overcurrent can be caused by short circuits, ground faults, or overloads. The National Electrical Code (NEC) provides detailed requirements for overcurrent protection. Article 240 of the NEC covers overcurrent protection. Section 240.1 states that overcurrent protection shall be provided in each ungrounded conductor of a circuit. This means that each hot wire in a circuit must be protected by an overcurrent device, such as a circuit breaker or fuse. Circuit breakers are automatic switches that trip and de-energize a circuit when an overcurrent condition occurs. Fuses are devices that contain a fusible link that melts and opens the circuit when an overcurrent condition occurs. The size of the overcurrent device must be selected based on the ampacity of the conductors being protected. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. The NEC provides tables that list the ampacities of different types of conductors based on their size and insulation. When selecting an overcurrent device, it is important to choose one that is sized appropriately for the circuit being protected. If the overcurrent device is too small, it will trip unnecessarily, causing nuisance outages. If the overcurrent device is too large, it will not protect the circuit from damage caused by overcurrent. Regular inspections of overcurrent devices are recommended to ensure that they are in good condition and that they are functioning properly. Any damaged or defective overcurrent devices should be replaced promptly. By properly providing overcurrent protection, you can help to prevent damage to electrical circuits and equipment and reduce the risk of fire hazards. Electrical boxes are enclosures that are used to protect electrical connections and devices. They are typically made of metal or plastic and are available in a variety of sizes and shapes. The National Electrical Code (NEC) provides detailed requirements for electrical boxes. Article 314 of the NEC covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handle enclosures. Section 314.3 requires that boxes be securely fastened in place. This means that the box must be attached to a structural member of the building, such as a stud or joist. Section 314.16 specifies the minimum size of boxes based on the number and size of conductors that will be installed in the box. The box must be large enough to provide adequate space for the conductors and any devices that will be installed in the box. Section 314.17 specifies the requirements for cable and raceway entries into boxes. Cables and raceways must be securely fastened to the box to prevent them from being pulled out. Section 314.27 specifies the requirements for the support of devices installed in boxes. Devices must be securely supported to prevent them from coming loose over time. When installing electrical boxes, it is important to follow the requirements of the NEC and local building codes. The box should be properly sized for the number of conductors and devices that will be installed in the box. The box should be securely fastened in place. Cables and raceways should be securely fastened to the box. Devices should be securely supported. Regular inspections of electrical boxes are recommended to ensure that they are in good condition and that they have not been damaged or corroded. Any damaged or corroded boxes should be replaced promptly. By properly installing electrical boxes, you can help to protect electrical connections and devices and ensure the safety of the electrical system. Conductors are wires that are used to carry electrical current. They are typically made of copper or aluminum and are insulated to prevent electrical shock. The National Electrical Code (NEC) provides detailed requirements for conductors. Article 310 of the NEC covers conductors for general wiring. Section 310.3 requires that conductors be insulated. The type of insulation must be suitable for the voltage and temperature rating of the circuit. Section 310.4 specifies the requirements for the ampacity of conductors. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. The NEC provides tables that list the ampacities of different types of conductors based on their size and insulation. Section 310.15 specifies the requirements for the number of conductors in a raceway. The number of conductors in a raceway must be limited to prevent overheating. When installing conductors, it is important to follow the requirements of the NEC and local building codes. The conductors should be properly sized for the circuit being protected. The conductors should be insulated to prevent electrical shock. The conductor should be installed in a raceway or cable assembly. The number of conductors in a raceway should be limited to prevent overheating. Regular inspections of conductors are recommended to ensure that they are in good condition and that they have not been damaged or corroded. Any damaged or corroded conductors should be replaced promptly. By properly installing conductors, you can help to ensure the safety and reliability of the electrical system.